Namah Shivaya. In this video, we are going to learn few important name reactions involving alkanes, alkenes and alkanes. Moving on to the next slide. Okay, it's not exactly a named reaction, but a rule bearing the name of a scientist, Markovnikov. In case, if we take a simple alkene and add hydrogen halide across this, these two carbon atoms, they are same. You can add H plus across either this carbon or this carbon. There will be no difference in the final product. However, if you take propene as the reactant and add hydrogen chloride across the double bond, obviously there is a difference between this alkene carbon and this alkene carbon. So now comes the role of Markovnikov's rule. What it says, in the addition of HX to an unsymmetrical alkene, hydrogen attaches to the carbon having more hydrogen atoms. So now in this H plus and Cl minus, the hydrogen attaches to the carbon having more number of hydrogen atoms, that is this CH2. So the product will be, and after that the Cl minus will go and attach to this carbon having less number of hydrogen atoms. So the product will be as shown here. See, you can see. So if I number like 1, 2, 3, hydrogen attaches to the first carbon and chlorine attaches to the second carbon. So chlorine with second carbon and hydrogen with first carbon. So this is given by Markovnikov's rule. So 2-chloropropane will be the product. So don't ever write this product. So it is wrong. So this may be formed in minor amounts. However, the major product will be 2-chloropropane. The next one is anti-Markovnikov addition. So this is an exception we have for Markovnikov's rule. In this case, the same propene we can take and hydrogen bromide is used and we take peroxide. So in presence of peroxide, hydrogen bromide adds across the double bond, not as expected by Markovnikov's rule, but in opposite to what it says. See here, H adds to the carbon which has less number of hydrogen. So it is exactly what was suggested by Markovnikov. So here 1 bromo, so bromine adds to the carbon which has high number of hydrogen atoms. So 1 bromopropane would be the major product. You can see here 2-chloropropane was the major product. So this effect is called as Kharasch effect. Remember, this happens in presence of peroxides and it happens only with hydrogen bromide. The same effect was not seen with HCl and HI. The next one is a reagent possessing a scientist's name, Bayer's reagent. What is Bayer's reagent? It is called dilute alkaline potassium permanganate. What is its use? So in labs, if an unknown compound is given and if we have no idea about the compound, we can guess whether the compound contains unsaturation or not by using this Bayer's reagent. So unsaturation means C double bond C or C triple bond C. Okay. So if it results positively, then we can say the given compound is an unsaturated compound. So what happens exactly here? So as we can see, the reagent contains KMNO4. The solution will be obviously purple in color. Then we add this purple colored potassium permanganate to the given compound. If decolorization happens, so you can see the photographs. So this is before the addition of our compound and this is after the addition of our compound. So the decolorization of permanganate takes place and this shows that the given compound contains either C double bond C or C triple bond C. So what exactly happens is this Bayer's reagent oxidizes the C double bond C and C triple bond C. Therefore, the decolorization of permanganate occurs. Sometimes you may see a brown precipitate settling at the bottom as well. The next reaction is Lindlar's catalyst reaction. So it's the name of scientist. What is Lindlar's catalyst? Palladium on calcium carbonate along with quinoline. So what is this catalyst used for? Now you take acetylene and you want to get alkene out of this acetylene by reduction. So when you take hydrogen for the reduction process, in practical sense, we may not be able to get all the times the alkenes. A complete reduction can happen leading to alkane. So to stop this, we are using this Lindlar's catalyst, which is palladium on calcium carbonate partially deactivated by quinoline. So the quinolin's role is to partially deactivate this catalyst, palladium catalyst. Okay, so what is the use of this deactivation? That is a partial deactivation. This stops the reaction at alkene stage. So alkenes do not happen. So this is one advantage of using Lindlar's catalyst. The second one is we get selectively a cis isomer while we use Lindlar's catalyst. Remember, we can use another catalyst for the same partial reduction of alkynes to alkenes, which is sodium and liquid ammonia. The isomer what we normally get is trans, but when we use Lindlar's catalyst, we get only the cis isomer majorly. That's all. We complete the named reactions in alkanes, alkenes and alkynes unit. Thank you. Happy learning.